Hello! Our lesson for this afternoon is all about evaluating functions. By the way, I am Miss Daisy Rodriguez Acas, your teacher today. For our objectives, at the end of this video, the learners must be able to evaluate functions and to solve problems involving functions. But what do we mean by evaluating a function? Evaluating a function means replacing the variables like x, y, or z in the function with a value from the function's domain and computing for the result. For example, given the following functions, f of x, which is equal to 2x plus 1, q of x, which is equal to x squared minus 2x plus 2, g of x is equal to the square root of x plus 1, r of x, which is equal to 2x plus 1 all over x minus 1, f of x, which is equal to the floor function of x plus 1, where the floor function of x is the greatest integer function, and t of x, which is equal to the ceiling function of x plus 1, where the ceiling function of x is the smallest integer function. Now we are asked to do the following. Number 1, evaluate the given functions at x, which is equal to 1.5. Number 2, find g of negative 4 and r of 1. Number 3, evaluate the following functions, f of 3x minus 1 and q of 2x plus 3. Now, to evaluate the given functions at x equals 1.5, let's start with letter A, the function f of x, which is equal to 2x plus 1. Remember, our x has given a specified value, and that is 1.5. And so, from the given function of x, all x's have to be replaced again with 1.5. Thus, this becomes f of 1.5, which is equal to 2 times 1.5 plus 1. Simplifying this one, this will become 3 plus 1. And 3 plus 1 is equal to 4. Thus, f of 1.5 is equal to 4. Now, let's proceed with letter B, the function q of x, which is equal to x squared minus 2x plus 2. Now, all x's, both sides of the equations, have to be replaced with 1.5, since that is the specified value that we are looking for, and that is said to be the given. So, q and x, so x is being replaced with 1.5, so q of 1.5 is equal to 1.5 squared minus 2 times 1.5 plus 2. Now, simplifying this one, this would give us 2.25 minus 3 plus 2. Then, if we are going to simplify this one, this will become 1.25. Thus, q of 1.5 is equal to 1.25. Now, let's proceed to letter C, which is the function g of x, which is equal to the square root of x plus 1. Again, all x's, both sides of the equation, have to be replaced with 1.5. So this becomes g of 1.5 is equal to the square root of 1.5 plus 1. Then if you're going to add these two numbers, this will become the square root of 2.5. And remember, there is no such integer root of 2.5. Thus, the final answer for g of 1.5 is equal to the square root of 2.5. Okay, for letter D, function r of x, which is equal to 2x plus 1 all over x minus 1, all x's has to be replaced with 1.5, both sides of the equation. So this becomes r of 1.5 is equal to 2 times 1.5 plus 1 all over 1.5 minus 1. Simplifying this portion here, this will become 5, 3 plus 1 rather. All over 1.5 minus 1 is equal to 0.5. Now simplifying again this fraction, this becomes 4 all over 1 half, since 0.5 is equivalent to 1 half. Now, this is a fraction with a fraction denominator. So if that would be the case, all you have to do is to copy the numerator, change the operation division into multiplication, and reciprocate the denominator. So we have 4 times the quantity 2 over 1, and the final answer would be 8. Therefore, r of 1.5 is equal to 8, given such function. Now for letter E, f of x is equal to the floor function of x plus 1, where the floor function of x is the greatest integer function. Now once we'll be talking about the floor function of x, it is actually the greatest integer that is less than or equal to the given specified number. Since the specified number is 1.5, replace in all x's both sides of the equation. So this will become f of 1.5, which is equal to the floor function of 1.5 plus 1. Now looking into the value of the floor function of 1.5, think of the largest integer that is less than a number that should not exceed 1.5. The answer would be 1, because it could be less than or equal to the given specified number, and that is 1.5. Thus, the floor function of 1.5 is 1. Then copy plus 1, so the answer would be 2. Now lastly, to the given function t of x, which is equal to the ceiling function of x plus 1, so replacing our x with 1.5, this will become t of 1.5 is equal to the ceiling function of 1.5 plus 1. Now when we talk about the ceiling function, this is actually the smallest integer that is greater than or equal. Take note, the smallest integer that is greater than or equal to the given value. And that given value is 1.5. So the answer would be 2. So the ceiling function of 1.5 is 2. So we have here 2, then bring down plus 1. And so simplifying this one, t of 1.5 is just equal to 3. Now, solving for example number 2, finding for g of negative 4 and r of 1. First thing is that we are going to copy the function g, and g of x is equal to the square root of x plus 1. In g of negative 4, the x is being replaced with negative 4. Thus, all x's must also be replaced with negative 4. So this becomes g of negative 4 is equal to the square root of negative 4 plus 1. If we are going to simplify this one, this becomes the square root of negative 3. Remember, if we are going to compute square root of negative 3 using our calculator would give us syntax error because the resulting value is an imaginary number. Okay? On the other hand, solving for r of 1, we have to go back to the original function r of x, which is equal to 2x plus 1 all over x minus 1. Now, our x is being replaced with 1, so we have to replace all x's from the given function with 1. So replacing it with 1, this becomes r of 1, which is equal to 2 times 1 plus 1 all over x here is 1 minus 1. Simplifying this one, so this becomes 3 because 2 times 1 is 2 plus 1 and that is 3 all over 0. But remember, this is called to be undefined. Hence, we could say that g of negative 4 is not possible because negative 4 is not in the domain of g of x, because the resulting value becomes an imaginary number. On the other hand, solving for r of 1 as well is not also possible since 1 also is not in the domain of r of x, because upon solving for r of 1, the resulting value is undefined. That makes it not possible. Now, proceeding to the last example, solving for or evaluating the functions f of 3x minus 1 and q of 2x plus 3, first we have to go back to the original function f. The given function f is defined as f of x is equal to 2x plus 1. Now remember, the x is being replaced with 3x minus 1. So all x's that we can see in here should also be replaced with 3x minus 1. So f of 3x minus 1 is equal to 2 times the x is 3x minus 1, then plus 1. And so simplifying this one, this becomes 2 times 3x is equal to 6x. 2 times negative 1 is negative 2. Then bring down plus 1. Then combine similar terms. The only similar terms in here are negative 2 and 1. And so this becomes 6x minus 1. Thus, evaluating f of 3x minus 1 is just simply equal to 6x minus 1. Now, evaluating q of 2x plus 3, we have to go back to the original function q. It is being defined as q of x is equal to x squared minus 2x plus 2. Now, replace x with 2x plus 3. So, all x's both sides of the equation have to be replaced with 2x plus 3. So, this becomes q of 2x plus 3 is equal to 2x plus 3 squared minus 2 times 2x plus 3 plus 2. Then if you're going to simplify this one, we would be able to come up with, this is actually square of binomials, special product rule number 2, square of binomials. To square the binomials, all we have to do is to simply square the first term. So 2x squared is 4x squared. The next step is to multiply the two terms by 2 as always. So multiply or square the first term plus twice the product of the first and second term. So 2x times 3 is 6x times 2, which is constant. So this becomes 12x. Then